Welcome viewers. Here is another example. We have to prove by induction. For all n greater than or equals to 2, that is n is natural number, we have the summation from 1 to n. R open bracket r plus 1 equals to 1 over 3 n open bracket n plus 1 close open bracket n plus 2. So here we have to show that this left side equals to the right side. I can rewrite this as everything divided by 3. So we have to show that this is true always. And how do we prove this? We have to prove by induction. And when you are proving by induction, you have just 2 steps. Step 1, you test for n equals to 1. And one thing about induction is once this proposition is true for n equals to 1, you assume that the proposition is true. But you need to show that the proposition will be true always. For the case the statement is true for n equals to k, you have to prove that it is also true for n equals to k plus 1. Your k can be any value. It can be 1 million, it can be 1 billion. So that is the reason why I've always assumed k. This is n greater than or equals to 1. So it's a subset of it. This is member of natural number, meaning n continue in that order. Now we can expand this. So you want to expand this side now. What this simply means is you want to expand it. You are starting from 1 to n. I can expand this. What you just need to do, put in 1. Once you put 1, you add. You put 2, you add. So this way, you write 1, open bracket 1 plus 1, plus you put 2, open bracket 2 plus 1, put 3, open bracket 3 plus 1, put 4, and you continue this way until you get to the last term. And what's the last term of this? So when you put n, we already have this. So the last term will be when we put n, so that will be n open bracket n plus 1. So this is the last term. When we add everything here together, so the result, our expected result is n plus 1, n plus 2. So this is our expected result. Now we want to prove that this statement is true. And if you are able to get that, it means the statement is what? Is false. And okay, we can further simplify this. Okay, this is 2. So we have 1 times 2. So we have 1 times 2 plus 2 multiplied by 3 plus 3 multiplied by 4 plus dot. Then we have n multiplied by n plus 1, which equals to what? n plus 1, n plus 2, everything divided by 3. Now the steps. N equals to 1, you test for n equals to 1. Now n equals to 1 here means the first term. What was the first term here? 1 times 2. Abi? 1 times. Let's check if our result here will be 1 times 2. 1 multiplied by 2 is 2. Let's check if the result will be the same here. So now our first time, that is proposition when n equals to 1. Our first time is 1 multiplied by 2. Now let's compare with this one. Put 1 inside it, so we have a 1, open bracket 1 plus 2. 1 plus 1, then 1 plus 2. We can simplify everything divided by 3. Simplify this so that we have a 1 open bracket 2 open bracket what? 3 divided by 3. By the time we divide by 3, we have a 1 times 2, which is 2. So this equals to 2. It means the statement is true when we check for n equals to 1. Now you don't need to check for n equals to 2, n equals to 3 again. What you need to do, you now assume that the statement is true for n equals to k, where a is also subset of a natural number. So now assume n equals to k is true. You assume that n equals to k is true. It means once you write everything here, what you only need to do, you replace letter n with k in both sides of the equation. It means when you sum up to k term, your result will also be k, open bracket, k plus 1, open bracket, k plus 2. Now let's do that. So now we have a pk, proposition k, pk, when we assume n, when n tends to k. So that will be 1 times 2 plus 2 times 3 plus 3 times 4 plus dot 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 k multiplied by k plus 1. Everything equals k, open bracket, k plus 1, k plus 2, divided by what? 3. Now we assume this is true. It means this is true. Once you make your assumption, then the next thing is to prove that n equals to k plus 1 is true. But before you prove that, you need to know where you are going. You know, anytime you are proving, you know where you are going. So now where are we going when n equals to k plus 1? Where are we going when n equals to k plus 1? It's very simple. Just go to the question. You know, here is the question. Here is the question. Or this one, anyone. So here is the question. So where in that question, wherever you see, you extend, you know, this series n at n. Here, this series n at what? K. It end at k. You need to generate the next term. And the next term after, for example, now the next term after 1 is 2, abi? After 2 is 3. After 3 is 4. After 4 is 5. How are we generating the next term? It's just increasing by 1, right? So now, next term after k will be what? That is k plus 1. So now we generate the term for k plus 1. And we write out the expected result. So now let's generate for k plus 1 now. Pk plus 1, that will be 1 times 2 plus 2 times 3. You know, you want to generate up to k plus 1. It's just like you stop, here we stop at what? 1, 2, 3. We stop at 3. It's just like you want to generate the fourth term. You know, you are still, it doesn't mean that you are going to neglect all this. We only want to extend up to k plus 1. So now we have a plus 3.4 plus dot dot dot. It means it continues that way. Then the next time here we have a k plus 1. So this is where we stopped earlier. Now we want to extend it. So now you introduce the next term. And you know this is k term. The next term after the k term will be k plus 1. So now what you just need to do, how do we generate the k term? Just replace letter k with k plus 1. So in this now, you replace letter k with k plus 1. Your final result also, you replace letter k with k plus 1. So let's do that. So now that is plus. Instead of writing k now, we write k plus 1. Then here also I write what? Open bracket, k plus 1 plus 1 plus 1. You know this is k. I change it to what? K plus 1. This is it. This is another k plus 1, then plus 1. You can see. Close this bracket. Then your final result will also change because definitely you introduce a term. So, and the expected final result will also be what? You change all this k also to k plus 1. So when we do that, we are going to have a, here we have a k plus 1. Then open the bracket, close it. Where we have k plus 1, when you change this one to k plus 1, you know, you have 1 plus 1, that will be k plus 2. K plus 2. Here also, when you change this k to k plus 1, k plus 1 plus 2, that is k plus 3. K plus 3. The everything divided by the value you have under, which is 3. So now, this should be our expected result. So that is what we should get. when we assume n equals to k plus 1. But how do we prove that this left side now equals to this expected result? How do we prove that this? Okay, this one also, you permit me to change this one now to k plus 2, since k plus 1 plus 1 is the same thing as k plus 2. So let's change it to k plus 2. It doesn't make any difference. If you don't change it, you are still going to change it later. Okay, maybe we change it later. Now, we want to prove that this side equals to this side. This is very simple. But don't forget, according to the rule, n equals to 1. You assume this is true. If this is true, k, n equals to k is true, then it means all this expression equals to this, definitely equals to what we have here. So remove this. We only use to generate this one. Now, it means everything. Now, you compare this with what we have here. It means all this, all this one, they are the same with this, right? It means I can replace all this with this result. Since this equals to this, then I can just use this one instead of all this long one. So I will write that k plus 1. Oh, sorry. We are using, everything here, which is the same thing, equals to this. So that is k, open bracket, k plus 1. Then what? K plus 2. Close the bracket. This is what we have, divided by 3. All this from here to this point, they are the same thing as this. And what we want to do, we want to show that all this side equals to that side. Now what is left in this side is this one. So now let's add it to this one. Since everything here equals to this, then we join this one now. So that is plus k plus 1, k plus 2. Don't forget, this is k plus 2. 1 plus 1, that is 2. Now what we need next, we need to simplify this. Let me use here so that we can have enough space to do that. From here also, you can just take your LCM. Everything here is over 1. Automatically is over 1. So your LCM is 3. I write 3 here. Now, divide by 3, you still have your k plus 1, k plus 2. This is just normal basic math. Also, now, plus, we divide by 3, you take LCM, 3. Divide by 3, you still have everything here. Now, plus 3 of everything here now. So that is just k plus 1, k plus 2. This is what we have. Let's simplify this further. K plus 1, k plus 2 is common. Can we just factorize k plus 1, k plus 2? K plus 1, k plus 2, k plus 1, k plus 2 is common. So we can just take it out. So we have k plus 1, k plus 2. They are common. Now what is left? When you take out k plus 1, k plus 2, you have just k. What is left here? We have just 3. So plus 3. Now let's compare everything divided by what? Divided by 3. Now compare what we have now with our expected result. Are they the same? Then it means we are able to show that the left side equals to the right side. It means that this statement is true always. And that is how to prove by induction. So you have 3 steps. N equals to 1. Assume n equals to k. You assume you are now going to use it. You use it to prove n equals to k plus 1. And that is how simple mathematical induction is. So watch out for more examples on this topic.